Hi guys, so I'm going to introduce to you guys the types of radiation, which are ionizing and non-ionizing radiation. So before that, we knew that the radiation referred to the energy emitted from a source. For example, heat or light from the sun, microwaves from an oven, X-rays from an X-ray tube, and gamma rays from radioactive elements. So this radiation is classified as ionizing or non-ionizing depending on its ability to ionize matter. So, what is the non-ionizing radiation? The non-ionizing radiation is the term given to radiation in the parts of the electromagnetic spectrum where there is insufficient energy to cause ionization. This kind of radiation cannot ionize matter compared to the ionizing radiation, which can ionize matter. It is a radiation with enough energy so that during an interaction with an atom, it can remove tightly bound electrons from the orbit of an atom, causing the atom to become charged or ionized either directly or indirectly. And the ionizing radiation can occur in two forms, which are the electromagnetic spectrum and also in particulate radiation. For electromagnetic radiation, in which energy is carried by oscillating electrical and magnetic fields traveling through space at the speed of light, it can have the non-ionizing and ionizing radiation, but only the high-frequency portion of the electromagnetic spectrum, which have high energy, is ionizing. For example, at the low-frequency waves that have less energy include infrared, microwaves, radio waves, and visible light is non-ionizing. But at the high-frequency waves that have more energy include ultraviolet, X-ray, gamma ray, is ionizing radiation. As I mentioned before, the ionizing radiation can occur in two forms, which are electromagnetic radiation that we have discussed in the previous slide, and also in the forms of particulate radiation. So, what is the particulate radiation? The particulate radiation consisting of atomic or subatomic particles which carry energy in the form of kinetic energy or mass in motion. So the example of radiation that occur in the form of particulate radiation is the alpha and beta particles which can directly ionize matter. The radiation that can ionize matter and cause damage to cell can cause by direct and indirect action of radiation on the DNA molecule. In the direct action, the radiation will deposit their energy in matter directly through many small column interactions with orbital electrons along the particle track. For example, alpha and beta particles are considered directly ionizing because they carry a charge and can therefore interact directly with atomic electrons through Coulombic forces. But for indirect action, the radiation will first transfer their energy to fast charged particles that is released in one or a few interactions in the matter through which the radiation passes, and then the resulting fast charged particles will deposit their energy directly in the matter. For example, the gamma ray and X-rays, which are electromagnetic, are considered as indirectly ionizing radiation. They are indirectly ionizing because they are electrically neutral and do not interact with atomic electrons through Coulombic forces. Besides, the neutron also is considered as an indirectly ionizing particle It is indirectly ionizing because it does not carry an electrical charge, so the ionization is caused by charged particles which are produced during collisions with atomic nuclei.
Now, let's talk about the radio wave. Radio waves are everywhere. They can come in the form of radio signal, 3G, Wi-Fi, and all that good stuff. Radio waves are a part of electromagnetic spectrum. They have the longest wavelength of 1000 meters. Radio waves have frequency as high as 300 GHz to as low as 30 Hz. At 300 GHz, the corresponding wavelength is 1 mm, and at 30 Hz is 10,000 km. The wavelength of a radio wave can be anywhere from shorter than a grain of rice to longer than the diameter of the Earth. Radio waves are non-ionizing radiation, which means they do not have enough energy to separate electrons from atoms or molecules, ionizing them, or break chemical bonds, causing chemical reactions or DNA damage. The objects, like planets, that have a changing magnetic field can produce radio waves. The Sun, Jupiter, and Earth emit radio waves called the radio bursts. The radio bursts are caused by the electrons that have been ejected into space during solar flares moving at 20% of speed of light.
So the next part is infrared. So infrared is also a part of a non-ionizing spectrum that is located between the microwave and also visible light. So when you have an electromagnetic spectrum, it will started with the radio wave and then microwave, and then we have infrared. And then we only have visible lights. So this infrared is located between this microwave and also this visible light. So infrared is actually a natural part of the human environment, and thus people are exposed to a small amount of infrared like in their daily life, whether they are at home or at recreational activities, which is the sun. So the sun is like the main natural sources of the infrared. So in our daily life, in many industrial process also involve in thermal curing of various kinds of material, which is thermal curing is the infrared itself. So only a person when they are exposed with a high level of infrared, only them are actually at risk, which is if they are exposed to a lot of infrared in a day, they are actually potentially at risk, which is dangerous for them. So what can I say here is when you hear about infrared, it's all about heat. So what does it mean here? Infrared is detecting heat. Even when your body or the surrounding is actually cold, you can still detect the temperature by infrared. Okay, so infrared radiation inside. So you can see here, this is an example image when we are detecting using the infrared radiations. So you can give like different colors, which is the blue one is actually a colder part of regions, and this the reddish part inside this image shows a higher temperature. So it really related to the heat, whether it's cold or it's hot. Okay. So here I attach is the sources of infrared. So as you can see, this is the main sources of infrared, which is the sunlight. Okay, and this sunlight will actually produce infrared radiations to what? To outdoors workers like construction workers or general public workers that are working in open space of situations or open space type of place. Okay, we have tungsten filament lens, we have light emitting diode, we have xenon, we have ion melt, infrared, and also infrared in the hospitals. So Here I also attach types of electromagnetic spectrum and their wavelengths. Okay, so somehow when you talk about infrared, so we have lasers that use in medical and also industrial process. So somehow if we use like a lot of lasers exposure, it will also emit a high level of infrared. Because what can I say here is laser is a part of infrared when it is overexposed actually. We move on to the applications of infrared. So here are a few applications of infrared. So first of all, we can see here is the night vision device. So you can see here this person is standing in the dark, but when they use an infrared device, they can detect a person in the dark by giving, you can see the image clearly with the black color shirts, and their face can be seen clearly, right? So basically, infrared is used in a night vision equipment when we don't have like enough light to visible a person. Okay, so this how are this night vision device processed is actually they involve like a conversions of ambient light photons into electrons, and then they are amplified, they are processed. Okay, so infrared will increase in the dark visibility without actually using a visible light source. Okay, so when you are using a night vision source, you cannot be confused with a thermal imaging. Because of what? When thermal imaging is actually create image based on the temperature, while this night vision device is actually detecting a person in a dark place. So please do not be confused with this thermal imaging and also night vision device. All right, and then we have a thermography image or thermography applications. So here we can see thermography. It's actually they can determine the temperature profile of a space shuttle thermal protection system. So like in a space shuttles, when you use like infrared, you can see the temperature profile inside it. So this part will be like a colder part. This part will be like like a warm part of it. So it produces image in radiations is actually right. And then we have like thermography like important, like not important, it's extra notes. So when you are using like a thermography camera, it's actually it is emitted by all object based on temperature. So it is according to like a black body radiation law. So this thermography is actually it makes it possible to see one's environment with or without visible illuminations. So once the temperature is increasing, this thermography allow one to see variations. So when the temperature is increasing, you can see like a reddish part in the image. So when a colder part, which is temperature is lower, you can see like a blue color image. All right. And then we also have a hyperspectral imaging. It is like a picture containing continuous spectrum through a wide spectral range in each pixel. So you can see here, okay, it can see the image according to a pixel. So like this part, it's having like a higher spectral of imaging, okay? So this can be performed using a thermographic camera as well. So what can I say here? Thermographic camera is widely used in almost all the activities in daily life, right? And then we have like a tracking. So what does this tracking also name is infrared homing? It refers to a passive missile guided system. So basically this tracking is mostly used in the military because it is really important in tracking system. All right. So it also known as a heat seekers, where you can see if you can see the heat, they will detect the movement and the heat or the visible of emotion according to the heat. So when it's like it's having a high temperature of motions, and then it can detect, and it also can track the motions and also the location of anything when you are tracking anything lah, right? And then we have last one is the health effect of infrared. You can see here, if you are exposed to overexposure of infrared, you can see like like a skin damage here, like a skin burns, right? So because it is a conversion of heat, so the main damage is the eye, including the iris and retina. So it's really important to wear the anything like a goggles when you are handling these infrared radiations. Okay, so the other damage are burn on the skin, and it also can result in the damage of the retina. And if it's overexposed to a person, it can result in the loss of consciousness. So that's all for the health effect of infrared radiation.
How about visible light? Visible light is a tiny part of electromagnetic spectrum. It is a form of electromagnetic radiation, as are radio waves, infrared radiation, ultraviolet radiation, X-rays, and microwaves. Generally, visible light is defined as the wavelengths that are visible to most human eyes. Visible light falls in the range of EM spectrum between infrared and ultraviolet. Visible light has shorter wavelength and higher frequency than the infrared. Visible light is the only electromagnetic wave that can be perceived by human eyes. Typically, the human eyes can detect wavelength from 380 to 700 nanometer. A color stimulus generally has a spectrum power distribution that varies with wavelength across the visible spectrum, producing a color or sensation that is a shade or mixture of the colors. It starts with violet that has the shortest wavelength and the highest frequency, all the way to red that has the longest wavelength and the lowest frequency. We can remember the order of the colors by the acronym of Roy-Gebief. Stimuli containing all the visible wavelengths in roughly equal proportions appear white. This is demonstrated by passing white light through a glass prism, which spreads the light out into a spectrum of colors. White light can be produced by superimposing red, blue, and green lights in certain proportions. It means that white is the combination of the all wavelength, while black indicates the absence of the light.
Assalamu alaikum. Hello everyone. I'm Ilham Mazwad, Master Medical Physics, USM. Nowadays, most people, when they want to go outside, they take their umbrella, wear glasses and protective clothes. So why is this? This is because there is a harmful type of radiation emitted from the sun that can affect our body and our health. Ultraviolet. Ultra means above or beyond, and violet the last color of the visible light. So UVR is a type of electromagnetic spectrum radiation, non-ionizing radiation, that has the wavelength from 100 to 400 nanometer, and positioned as you see between the visible light and X-ray. There are two types of UVR sources, which are nature and artificial. The main nature source is sunlight, solar UVR. It is classification into UVR A, B, and C. UVRC is the shortest wavelength and absorbed completely by ozone layer, so there is no effect on human. UVRB short wavelength and reaches to the outer layer of the skin, as you see, and can cause sunburn. UVRA, longer wavelength, and can penetrate to the middle layer of the skin and can cause skin cancer, skin aging, and so on. Man-made sources like fluorescent lamp, welding ARC, UV laser, and light emitting diode LED, and so on. The good effect of UVR is the protection of D3 by UVRB. The bad effect is in immune system. UVR modifies the molecules and becomes unfunction or foreign. This is not bad, but when there is infection or abnormal cell, so it will be a serious problem. As you know, the skin consists of three layers: epidermis, dermis, and hypodermis. As I said previously, UVA penetrates deeply in the skin and causes many effects. Sunburn, it is the red appearance of the skin following the frequently exposure to UVR. Photoaging, this is seen mostly in fishermen, farmers who are exposed daily to UVR. So you can see them dryness, tiny, superficial blood vessels. Prolonged exposure to UV will increase the risk of skin cancer. The structure of the eye protects it from the external effects, except the directly UVR. The short UV is attenuated in the lens, but the stronger UV can reach to the retina inside the eye. When this happens, you can feel itchy, pain, tearing, or sand in the eye, and may cause cataract. So, what is cataract? It is a cloud in the lens that affects your vision. If not treated well early, it can causes blinding. So finally, my advice to you, avoid UV as you can as possible because there is a lot of harmful effects. Be safe, be healthy. Thank you.
Okay, hi everyone. So I'll be explaining about types of ionizing radiations, which is included in alpha particles and also beta particles. So basically, we have electromagnetic spectrum, has been explained by my friend. So we know that in electromagnetic spectrum, it started with the radio wave, which is non-ionizing, and it is continued with ionizing until the gamma radiation, right? So basically, alpha particles and also beta particles is also considered as ionizing radiations because of what? Because they carry a charge and therefore they can interact directly with atomic electrons through a Coulombic force. So I'll be explaining first what is alpha particles. So as you can see here, alpha particles is considered as ionizing radiations because they are composite particles consist of two positively protons and also neutrons with no charge, and they are tightly bound together, and they also travel with a very high speed. Okay, so you can see here in the image I've attached in this slide, we have two protons, and these protons are positively charged, and also we have no charge of neutrons, so both of it are tightly bound together. Okay, so alpha particles is actually come from a decay of the heaviest radioactive element, such as we have like a uranium, and we have radium, and also polonium. So as you can see here, I have include types of radioactive decay or radionuclide decay, which is including the uranium, and it releases an alpha particles, or also known as alpha radiations. Okay, so even though these alpha particles is very energetic, but they are so heavy, uh, which means that they travel in a very short distance only because of this heavy atoms of alpha particles. So common alpha particles actually emit alpha with energy of kinetic energy between 4 and 5.5 MeV. So here are properties of alpha particles. So basically, when comparing with the most common form of ionizing radiations, such as gamma, alpha, and beta, so this alpha particles is actually having the greatest mass. Okay, so what does it mean here? It has approximately 4 times of the mass of protons and neutrons, which is it's approximately 10,000 times the mass of beta particle, and it traveled much slower. Because of what? Because it's heavy. When it's heavy, it is difficult to travel. So it also, you can compare it with our with humans. So if we are big, we travel slower compared to a slimmer body person that can travel faster, right? So because of this large size of alpha particles, it has a highest ionizing power, and it has a greatest ability to damage tissues. Okay, so because of this large size, it makes them less able to penetrate into the matter. Okay, and they brought to a rest by few centimeters of air, and or less than a tenth of millimeter of biological tissues. So as you can see from this image, this alpha particle can only travel a few centimeters, all right, few centimeters in air. And you can see here, this alpha particle, it travels 5 to 7% of the speed of light. So it means that it travels lower, okay? So in other words, these alpha particles you can see here, okay, it can be blocked by a sheet of paper, okay, or can be stopped by a thick sheet of sorry, it can be stopped by a thick sheet of paper, or even a layer of clothes, okay, and they can stop by a outer layer of a dead skin on a people, right? So basically, so once this alpha emitters is inhaled or taken in food or water that we consume, so once this alpha emitter is inside our body, it has no longer protections, which means it can only destroy all your DNAs and our living tissues, sensitive living tissues inside our body. So that one I'll be explain more in the health effect. So wait. So we have here is the applications of alpha particles. So I've attached 4 applications of alpha particles. So here we have alpha particles is being used in a smoke detector using the uranium-241. So the alpha particles from this americium-241, it will be bombarded in the air molecules, which it will knock the electrons free, and these electrons are basically used to create electrical current. So somehow it will trigger an alarm when they detect a smoke. Okay, and the second one is the static eliminators that used polonium 210, which is also emit alpha particles here. Okay, so the positive charge from the alpha particles is actually will attract the free electrons, and thus it will reduce the potential of local static electricity. So here actually static eliminators are usually used in paper mills. Okay, and then we also have been used in radioisotope thermoelectric generator using this plutonium 238. What does it do here is actually it will generate heat that will convert it to electricity, and somehow it is only used in space probes. Like you can see here, this is sort of a radioisotope thermoelectric generator. Well, you can see in this picture it's not that clear, but this is an example of plutonium 238 source that will somehow emit alpha particles. And then it also used in cancer treatment that will use a small amount of radium-236. So basically, these some alpha emitters are being investigated for their potential use in the unsealed source, where what does it do here? This radium-226 will be inserted into a cancerous masses. So these alpha emitters or alpha particles will actually destroy the cancer cells, but it is lack the penetrating ability to damage the surrounding healthy cells. So it's really effective in using in the cancer treatment itself. Okay, so somehow it's still used in the bone treatment, as you can see from this image. So this radium-226 is inserted in all these cancerous masses or tumors. It will destroy the cancerous cell. And last part, we have the health effect of alpha particles. So basically, alpha particles, as I mentioned, it is not dangerous at first, but once we inhaled or we swallowed or we ingested these alpha particles, it really harmful inside our body. So basically, alpha particles, the health effect is depends on how a person is exposed. Okay, so since alpha particle is lack of energy to, penetrate at the skin of a person, so the health effect is actually not a major concern. But once it's emitted or once it is inside our body, it is really, really, really harmful. So it's really important once to avoid these alpha particles from penetrating inside our body. All right, so because it's highly ionizing, and it will result in a severe damage to the cell's DNA. So that is somehow the health effect. So, or what I can say is the health concern when we are handling alpha particles. Okay. So, the next one I'll be explaining about beta particles. So, what is beta particles is? So, these are types of beta particles which it's actually similar to electron. So you can see from the image it is electron, okay? And they are emitted from a naturally occurring materials. So what are natural occurring materials are radionuclides, okay? So such beta emitters is widely used in medical applications such as treating eye disorder. This one I'll be explaining later in the applications of beta particles. So generally, beta particles it's actually are small. So because it's similar to electron, it is a fast-moving particles with a negative electrical charge that are emitted from atom's nucleus of radioactive decay. So these particles are emitted by a certain unstable atoms I mentioned, like natural occurring materials. So such radionuclides are tritium, we have carbon, and also we have strontium. Okay, so beta particles is actually consist of high energy, high speed electrons or positron that are ejected from the radionuclides. So what I can say here is high speed electron positrons, okay, are actually emitted from this radionuclide, and it is known as beta particles. All right, so these are ejected from radionuclides. So how are they ejected is from a radioactive decay. So radioactive decay is also known as beta decay. So basically beta decay will emit beta particles. All right. So the least energy of beta particles required is 70 keV in order to penetrate into epidermis. Epidermis means a deeper part of human's body. Okay? And beta particles are typical low LET radiations in that travel in air, approximate 3.65 meter per MeV of kinetic energy. All right. So, to be added in these beta particles, so basically, often gamma ray is also emitted accompanied with the emissions of beta particles. How is that happen? Is when this beta particle ejections doesn't reach the nucleus of extra energy. Okay, so when they does not release extra energy, the nucleus release excess remaining energy in form of gamma photons. So basically gamma photons will always accompany with beta emissions or beta particles. So we move on to the properties of these beta particles. So beta particles is actually much smaller, which is over 77,000 times lighter than alpha particles. And because of its smaller mass, it is able to move further in air, which is up to few meters. Like I said, in alpha particles, it only travel up to few centimeters, but in beta particles, they can travel up to few meters, and they can be stopped by a thick piece of plastics or even a stack of paper, such as a metal like aluminiums. All right. So because of its smaller particles, it has a lower ionizing power compared to alpha particles. Right. So, for example, in alpha particles, okay, a very high energy of beta particles will travel um half an inch through a plastic before it uses up all the energy. All right. So, like alpha particles, beta particles, similarity with both of these, beta particles will lose its energy with every interactions, and they will produce no ions once all the energy are spent. So it has their energy. Once their energy are all spent, they will no longer produce ion. All right. So the health concern that associate with these beta particles is primarily affected when this beta emitting are ingested or inhaled. So similar also with the alpha particles, what makes it hazardous to the human is once this beta particle source gets inside our body. So it's really dangerous. Right. So we move on to the applications of these beta particles. So similar to alpha particles, so these beta particles also apply in our mostly in daily life. All right. So first of all is its uses in brachytherapy, where it's irradiate inside the patients to prevent from the growth of the tumors. So this brachytherapy uses a radioactive that will produce a beta particles that in order to prevent the growth of tumor to happen. All right. So next one, beta particles is also uses in PET scanning that uses fluorine. So fluorine 18, okay, will somehow emit beta particles that will really helpful and really effective in PET scanning or diagnosis patients' health conditions. All right. So next one, beta particles is also used in the emergency light where they use tritium, okay, as I mentioned, because this tritium will produce like a fluorescence light that will help food in the emergency light. And what does make it special is it does not require power. Okay, so rather than we use electrical power to produce emergency light in a dark space, so we can use tritium that will produce like a fluorescent light in helpful with the emergency light. Okay, so next one, it also used as a gauge thickness of films of material coming from a production lines. So what does it mean here is actually the thickness of the detector for the quality control of thin materials, which means this beta particle is really helpful in a quality control. When we want to detect the quality of a paper, we use this beta particle emissions. All right. And the last one, it's always and forever been effective way in order for the treatment of eye and bone cancer because we use strontium. So this strontium is actually will prevent and also will detect the eye and the bone cancer because it has its own effectiveness and it has its own way in order to accumulate at the tumor at the eye and also the bone. All right. And the last part is actually the health effect of the beta particles. So similar to the alpha particles, the most important and the most major part is when you are exposed to beta particles. All right. So basically, when you are exposed with a beta radiations for a long time, especially your skin, it will result in a skin burn. All right. So it's really hazardous to the eye itself when this beta particle interact with eye. So therefore, it is really important while you are handling this radioactive nuclide that are producing beta particle. It's really important for you to wear a lead glass or lead glove because the eye is like the most sensitive organ or sensitive part of the body that will interact with the beta particle that will result in the blindness. All right. So, so these beta particles can also enter the body through unprotected wound. So it's really important when you have a wound and you want to handle a radioactive material that producing beta particles, you need to protect your wound, right? So once you inhale, the most important part is do not inhale these radioactive when this radioactive material that will produce beta particles because it will directly damage the internal organ and also the when we inhaled the beta particles radioactive material. So it's really important for you to really avoid um all this these methods by inhaling, ingested or swallow this beta particle or radioactive decay that will producing beta radiations. So I think that's all for beta particles.
X-rays were discovered in 1895 by German physicist Röntgen by producing a photographic image of the bones of the human hand. What is X-ray? X-ray is a form of electromagnetic radiation similar to visible light, but it has higher energy and can pass through most objects including the body. If X-rays traveling through the body also pass through an X-ray detector on the other side of the patient, an image will be formed that represents the shadow formed by the object inside the body depending on the tissue density of the body. So, as fast-moving electrons in the beam interact with the electrons and nuclei of the target atoms, they are repeatedly deflected and slowed and emit Bremsstrahlung radiation. In addition to the continuous spectrum of radiation emitted by the decelerating electrons, there is also a spectrum of discrete X-ray emission lines that is characteristic of the target material. A collision first causes a tightly bound inner shell electron to be ejected from the atom. A loosely bound outer shell electron then falls into the inner shell to fill the vacancy. So, what is the uses of the X-ray? X-ray can be used in diagnostic and therapeutic field. For diagnostic, X-ray radiography detects bones fractures, certain tumors, and other abnormal masses. X-rays travel through the body and are absorbed in different amounts by different tissues, depending on the radiological density of the tissue they pass through. As for mammography, it is a radiograph of the breast that is used for cancer detection and diagnosis as well to detect microcalcifications, while CT combines traditional X-ray with computer processing to generate a series of cross-sectional images of the body that can later be combined to form a 3D X-ray image. Fluoroscopy uses X-ray and a fluorescent screen to obtain real-time images, while in therapeutic field radiation, there are two main types of radiation therapy, which are external beam and internal beam radiation therapy. External beam radiation therapy comes from a machine that aims radiation at your cancer. Some of the machine that uses the external beam radiation therapy is 3D CT, IMRT, and IGRT. So 3D CT is a common type of external beam radiation therapy, while IMRT is a type of 3D CT, but it uses many smaller beams than 3D CT, and the strength of the beam in some areas can be changed to give higher doses to certain parts of the tumor. While IGRT is a type of IMRT, it uses imaging scans not only for treatment planning before radiation therapy session, but also during radiation therapy session. While internal radiation therapy, it uses source of radiation whether it can be solid or liquid being placed in a patient's body. Internal radiation therapy with a solid source is called brachytherapy, while with liquid source is called systemic radiation therapy. Systemic radiation therapy can be done by swallowing through a vein via an IV line or through an injection. Techniques for placing brachytherapy include interstitial brachytherapy, in which the radiation source is placed within the tumor, intracavity brachytherapy, in which the radiation source is placed within a body cavity or a cavity created by surgery, and episcleral brachytherapy, in which the radiation source is attached to the eye. There are three types of brachytherapy, which is low dose rate LDR, high dose rate HDR, and permanent implants. LDR is a type of brachytherapy where the radiation source stays in place for 1 to 7 days, while for HDR, the source is left in place for just 10 to 20 minutes. And lastly, for implants, it remains in the body for the rest of life, but the radiation gets weaker each day due to its half-life. Wavelength and the most energy of any other wave in the electromagnetic spectrums. These waves are generated by radioactive atoms and in nuclear explosions. Gamma rays can kill living cells, a fact which Maxence uses to its advantage, using gamma rays to kill cancer cells. Gamma rays mainly come from two sources, radioactive materials and cosmic interactions. Radioactive materials are unstable and have a lot of excess energy. When they decay into simpler materials, they give off dangerous radiations of various types, one of which is gamma radiation. When gamma rays are produced from radioactive materials, it is through a process called gamma decay. This is where an unstable radioactive atoms are able to release some of their high energy by emitting a gamma ray. But gamma rays can also form in high-energy cosmic interactions of charged particles in space, such as in active galactic nuclei at the center of galaxies. Most of these cosmic gamma rays are screened by Earth's atmosphere and don't make it far enough to be detected. Gamma rays can also be produced after lightning strikes and randomly in the atmosphere during thunderstorms. Gamma rays can be produced by four nuclear reactions, which is nuclear fission, alpha decay, and gamma decay. Nuclear fusion is the reaction that powers the sun and stars. It occurs in a multi-step processes in which four protons or hydrogen nuclei are forced under extreme temperature and pressure to fuse into a helium nucleus which comprises two protons and two neutrons, while nuclear fission are a splitting of a heavy nucleus into two roughly equal parts, which are then nuclei of lighter elements. Alpha decay occurs when a heavy nucleus gives off a helium-4 nucleus, reducing its atomic number by 2 and its atomic weight by 4. This process can leave the nucleus with excess energy, which is emitted in the form of a gamma ray. Gamma decay occurs when there is too much energy in the nucleus of an atom, causing it to emit a gamma ray without changing its charge or mass composition. So the uses of gamma rays is sterilized medical equipment, sterilized food which is been irradiated, used as tracers in medicine, radiotherapy in oncology to kill cancerous cells, and gamma ray astronomy as well. So the difference between gamma ray and X-ray is how they are produced. Gamma rays originate from the settling process of an excited nucleus of a radionuclide after it undergoes radioactive decay, whereas X-rays are produced when electrons strike a target or when electrons rearrange within an atom. Thank you.